Got a quick and dirty rundown of the project I've been working on. I basically took a PIC 18F 2420 and used it to drive two servos and a airsoft gun. And the way I did that was I'm using three timers to generate my pulses, and I haven't looked at this in a while, so it's going to take me a second. Using timer 0 basically as the 60 hertz generator, and the way it works is timer 0 starts first, and then once it triggers, it just goes up the line. It sets up timer 1's basically a period, and then enables it. So then timer 1 overflows and equally sets up timer 2. And then once timer 2 overflows, it starts back over and starts timer 0 again for the 60 hertz wave. And what I've got is timer 1 and timer 2 are both a servo. Timer 1, I believe, is the pan, and timer 2 is the tilt. And then what I've got here is I've got hard-coded limits in there to keep them from hitting the base. These are, I think they're the high torque. I can't remember what I installed in there, but if they're high torque, if they went past the limit of the bracket they're in, they could basically damage themselves or the bracket. So I've got them hard-coded min and max so that they can't ever contact herself. And then what I've got is I've got a USART. I'm sending async communications to and from the PIC, and I'm running at 57,600 is my baud rate. And right now I've just got it set up to only receive. And what I've got a ring buffer that basically it checks to see if there's data on there, and then it puts that data. Let me go back up there. Whenever data comes in, it raises the RCIF flag, and I take that data and I put it in an array. And I've got a head and a tail. The head is where I'm reading from. The tail is where I'm putting into. So I've got a array that is a dynamic size. It's 48. And basically it loops or overlaps at the end. Once it hits the end of the array, it resets back to the beginning and starts stuffing it in there. And what that allows me to do is I can just throw data at it all day, every day. And once I get time to process this, I can read it out. So throw data in at the tail, read it out at the head. I've got some checks in there to see if the head and the tail are equal. I can tell if it's full or empty. What this method has allowed me to do is, should I ever take more data in than it's processing, I can error detect and just scrub it out. So if it ever, and right now it hadn't been a problem, I haven't bottlenecked at all, but if I ever sent so much data that it couldn't process it, it wouldn't be a big deal because I could have code that would detect whenever it started getting garbage and just to flush the buffer and then start fresh. So pretty simple. I've got limit switches in here. This runs at the end of the loop, and it just enforces my hard min and max for each servo. Okay, and then onto the C# application. Not real good at C#, but I'm getting better. Kind of the same principle here. I had to use a modifier, and I'll show you that down below. But basically, all this is I've got a bitmap that is the exact size of the resolution of my servos. My servo can go left and right, 1,500 points of movement. So I've got 1,500 wide by 600 tall, and again, I've got a tilt of 600 positions. Then I've got my basic port settings here that connects. I've got mouse tracking. And then when the airsoft cannon's on there, basically whether it's in fire mode or if it's in just a dummy state. So the rundown of that, it's really not a whole lot going on. I had button clicks originally, and it's tedious to do, and it's kind of crap way of doing it, to be absolutely honest. It took me a couple ways to figure out how to get the mouse move to work and the key detection. If you want to detect keys and you have any type of edit box, you have to use process command key. I tried actually polling for the key pressed, and it would work as long as I wasn't hovered over a state or I wasn't in an input. The second you go in an input, you can't read key states without process command key. So that's a must. And all I've got a boolean enable disable, and it's a toggle state. Basically, if it was not enabled, when enabled, I clip the cursor to my application. That way the cursor can't leave it. And more so, I clip it to the picture. That way, when it's in the tracking state, I can't ever be a pixel out of the resolution of my servos. And then just some visual stuff here. The real magic happens on timed event. Basically, I've got a timer in there that's sending the position every, looks like 100 milliseconds. I was sending it nonstop and it was over processing. It really didn't matter. So right now what I do is every 100 milliseconds I make sure that I am connected. Just make sure that I've set up and connected to the serial port and enabled, which means I'm in the tracking and fire mode. So when those two states are made, I just check to make sure that the mouse has moved. If the mouse hasn't moved from its last state, there's no point in sending the data, so I'm not going to do it. So if the mouse has moved, it's another bool or boolean. I'm going to get the current X position and subtract it from the width of my picture box. And the reason I did that was my tracking was backwards. When you moved left, it went right, and when you moved down, it went up. So the easiest solution there to invert that was to take my reference not from the upper left 0, 0, but to actually take my reference from the bottom right, which would be, you know, 14.99 and 5.99. So once I've got that, my pick is basically using comma delimiting. So I send it the command, which is X, the X axis, and then comma, so it knows it's the end of the command. And then I convert that raw position into a position my controller can understand. And the way I did that was kind of tricky. I took the X and Y modifiers are the minimum value on both axes. So I know at the minimum value, if I add 0, I'm at that minimum amount of track. And then if I add, obviously, the full width, or the inverted full width, if you want to get technical, of my picture's width, it would be 1500 plus the minimum, and that would be my total range of stroke. Same thing with Y. So then all I do is I make that into a string. So I take X, comma, that's command, the value I want it to move to, comma again to say that's the end of the number, and then command again says it's the end of the command, value, and then it ends it. And then I'm just sending that out with a serial port write. I was doing serial port write line, but I didn't have my pick set up to reject that new line character, and it was screwing everything up. So once it's transmitted, it just resets false to the mouse move, which will get flipped on as true on mouse move here. So anyway, we'll go ahead and fire this up. It's pretty simple. The defaults are already in there. This is the COM port I normally use. I hit connect, and it's connected. Serial port's open. Now I've got it set up to F5. When F5 is on, I'm bound to this bitmap, but also I'm sure you can hear it in the background. It's moving to those positions. And see here at the upper left, I'm at minimum and minimum, and down here is maximum and maximum. That's before my inversion though. So before, when I was at the bottom right, when I would go all the way to the right and down, it was all the way to the left and up. So I just flipped that around. But I've been dabbling with this for too long, to be honest. I finally got it working. I was really happy. So there it is.